Hello and welcome to this video presentation with the title One does not simply RSVP mental workload to select speed reading parameters using electroencephalography. This work was done at the LMU Munich, and I'm presenting this work on behalf of my co-authors Albrecht Schmidt, Simon Tannhäusers and Louis Chung. And in this talk I'm going to talk about how we can read using a paradigm called rapid serial visual presentation on devices with small screen spaces, and how we can actually find good parameters that optimize the information intake using RSVP. Looking at how we read media in the past, most of you will probably use books or magazines, media that is printed. While this media allows you to skim very fast through text, more and more people are going to digitize this printed media on electronic devices. This enables you to carry a lot of books with you in a digital manner, and this text is displayed on a display. However, with the shrinking manner of wearable devices, we see that this text becomes more and more difficult to be displayed. So for example, smartphones, smartwatches and smart glasses, the text representation is not optimal anymore, as you can see in these examples here. One paradigm to cope with this is RSVP, where one line of text with one word per line is displayed on a specific device and in a specific manner. Here you can see an example of how this looks like. So apparently you can just read the text by just focusing on the words that are displayed one by one next to each other. And this allows you to read on devices with small screen spaces that are capable of presenting one line. Additionally, it is claimed that you can read faster using this paradigm by enhancing the text alignment and by enhancing the speed. You can actually read and consume text faster. Related work has looked into what are good RSVP parameters and how can they be adjusted while reading. So for example, here we have related work from Dingler et al., where users read on a smartphone, smartwatch or on smart glasses, and they can adjust several RSVP parameters, for example the speed, by using such gestures. However, to most of the users, their optimal RSVP reading speed is unknown. So when you start reading for the first time, you have to try out different settings, and maybe after some time you have to readjust these settings again because you're reading for a long time and your cognitive capabilities are deteriorating for the actual reading task. Looking further into related work, Zayev and colleagues found out that you can also have a good reading performance while walking and reading with RSVP. Related work has informed us about two particular parameters that can be manipulated that manipulate your reading efficiency. One of them is the presentation speed. Presentation speed can be increased so you can read faster or slowed down so you read slower. The second parameter is the text alignment, and the text alignment judges how much eye movements you include into your actual reading task. And the more eye movements you have to include into your reading task, the more time you lose. It makes it really difficult for beginners and people who are using RSVP over a long term of time to find their optimal parameters regarding presentation speeds and text alignment. I argue that current RSVP applications require users to set the reading speed and reading parameters manually. However, finding parameters that optimize the reading efficiency are often unbeknownst to the user, which means they have to employ a brute force approach. They have to set the speed and the parameters while reading, which puts additional cognitive load on the user. And it would be nice to have a method to assess this automatically. In this work, we are using physiological sensing, specifically electroencephalography, in short EEG, as a measure for cognitive workload and working memory to assess different RSVP parameters for future BCI systems that select the presentation speeds and text alignments automatically. Let's have a look at the different presentation speeds so you can get a little bit of a notion how this looks like. So first of all, let's have a look at 200 words per minute, 350 and 500. As you can see, 500 is way faster than 200, And when you're not used to RSVP, it becomes difficult to follow 500 words per minute. At the same time, when watching too long for 200 words per minute, you may become bored because it takes you a lot of time and cognitive effort to read the actual text. And of course, you can vary this over certain spans. You could also go for 250 and 300 words per minute to set your suitable reading speed. But the question is, what is the reading speed you can read for a long term of time? For the text alignments, you can see here that we selected in our experiment 3 different text alignments. So the first is a centered representations, where we represent with dotted lines the eye movements you have while reading. So for example, when you center a word, you can see that between red and brown and fox, the dotted line represents the eye movement which is included while reading this. Hence, you will lose time because you have to move your eyes. Next, we look into a fixed centered character where we focus, for example, on the second character, and you have a very steady eye movement because you can approximate the text to the right. And also you can color the fixed centered character to make it easier for the participants and your users to recognize what character they should read. Hence, we conducted a study in which we wanted to evaluate what are good RSVP parameters, and we employ EEG as a physiological measure to measure the working memory and task engagement that is placed on the users to see if we can use this as a predictive metric to assess the suitability of speed reading parameters. Looking at the methodology, we have a user study with 18 participants, and each of the participants did 10 reading trials. One reading trial with a baseline where they read a full text PDF on a screen, and 9 other reading trials where they were reading with different RSVP parameters and text alignment. We opted in for a within subject design, so each participant read every text with every RSVP setting, and our dependent variables were the time to read a full text PDF, which is essentially the baseline, and we measured the time to see how fast the participants are reading anyway. We measure subjective workload using the NASA TLX questionnaire and the text comprehension. The texts we used were from a standardized RSVP test set, which were accompanied by text comprehension tests. And using these text comprehension tests, we could see how well participants understood text. Finally, we measure electroencephalography. And this is how our experimental setup looked like. With EEG, you put a cap on a participant's head and put electrodes in it. And what you measure are the electrical brain potentials emitted by the human brain. We have opted in for a layout on the back of the head and the front of the head. The back of the head is known to correlate with working memory, a cognitive system which can be briefly described as the short-term memory system, where you memorize information for a very short amount of time and you store them or you modify them and do another output with them. At the front of your head, you have you can measure the so-called theta power, which is a measure also for cognitive workload, but also for task engagement. With this, we wanted to know if we can measure the task engagement and the cognitive effort of our participants while reading with RSVP. And this is also interesting because everybody has an individual reading behavior that also changes over time. And having such a measure, we are able to assess the usability of the RSVP parameters, which can be then also automatically adjusted by future BCI applications. We go to procedure and data processing, and for the procedure, 9 of these texts were read with different presentation speed and text alignments, and 1 PDF was read at the beginning as a regular PDF full text baseline. After each of these trials, so 10 times, a text comprehension test was filled to see if the participants were understanding the text, and a NASA TLX questionnaire to get a self-rated measure. Looking at the results for the alpha power first, which is a measure for working memory, we find that for 500 words per minute, participants had the least working memory, which was a little bit contradictory to our expectations because we would assume the faster you have to read, the more information you have to store, so the working memory would be really high and we would have a very low alpha power value. At the same time, we find that for 200 words per minute, we have very high alpha power. And when we look at the theta power, where the correlation is inverse, we also find that participants had the highest task engagement and the highest workload while reading with 200 words per minute. And actually the least workload and task engagement with 500 words per minute. And you can also see that all of these results are significant. And that was contradictory to our hypothesis. So we were thinking maybe 500 words per minute was the perfect fit, and this is why participants had the least workload, and maybe they were bored with the other presentation speeds. But when looking at the subjective workload, participants rated also the 500 words per minute as very cognitive demanding. And this is somehow a mismatch, right? Because participants rate 500 words per minute are really demanding, but at the same time, the EEG data reveals that participants had only very low workload with 500 words per minute. Looking at the text comprehension scores, this echoes the NASA TLX. Actually, we find that the lowest text comprehension was achieved with 200 words per minute for all of the text alignments. It is interesting to note that we always had a significant difference between at least one of the presentation speeds, but for none of for the text alignments. Asking the participants why this could be so, most of the participants answered that with 500 words per minute, it was so fast and they were so unused to it that they were just not reading anymore. And this hints a little bit into that there was some sort of cognitive overload to the participants, so they were not processing the information anymore. And there was also no task engagement anymore because they were not immersed into this actual task. And this is also conform with the text comprehension test and the self-rated NASA TLX. Looking at the predictive model, which we have generated, we see that we can find a linear correlation between the alpha power and the theta power. For this, we took the regular reading speed as a baseline, and we divided the regular reading speed through the actual reading speed, which we have from the RSVP parameters, to see how much speed the participants gained. A speed gain below 1 means that the participant was reading slower than regular with the regular reading speed, which we elicited and measured during the baseline. And the speed gain factor larger than 1 means that the participants were reading faster, so the RSVP had an advantage over regular reading. We correlated this with the power we got and plotted this against the speed gain factor. And what we find there is a really nice linear curve which enables us to estimate the current reading speed using the alpha power or theta power alone. So what does this mean now? If we have a value such the alpha power or the theta power and we submit it, we get the speed gain factor, and knowing the actual baseline, we know if the participant is reading now with a suitable speed that approximates the baseline in terms of cognitive load as the participant would usually read. This means that such a regression can predict this, and this could, for example, be used by BCI applications to set the RSV speeds automatically or analyze reading speeds regarding their reading capabilities of the user if they were really reading a text. As for the discussion, we know now that EEG assesses the cognitive demand of RSVP reading speeds, and EEG predicts the current reading speed relative to this reading baseline, which is the speed gain factor. What we find is that the presentation speed is a major limiting factor. So if you turn up the presentation speeds, people are either cognitively overloaded and not reading anymore, but at the same time, with lower speeds, you get participants to read your text again. So presentation speed is the main factor future RSVP designers should focus on rather than text alignment. As a use case, and as I said before, you can set the presentation speed automatically in future BCI applications. At the same time, you can reflect the text passages that have been read. So for example, if you have mind wandering, you can reflect on this and see which parts of text have not been read yet. As for the limitations and future work, we have approximated the free number of presentation speeds we have used in our study, but the overall aim was that we have the regression for this, which approximates and interpolates the values in between. We also cannot disclose that the participants had previous knowledge of the text comprehension test. So if somebody already knew the solution, then that was already known by the participant, and there's nothing we can do against this. Also, we don't know if there's an effect of long-term use of RSVP because none of our participants was used to RSVP before. With this, I want to close my presentation. Thank you very much. And if you have questions, don't hesitate to contact me by mail. Thank you very much.